Welcome back. So to better understand the concepts and the theories we spoke about in the class, we have to apply the knowledge in trying to solve certain problems that would help us deepen our understanding. Okay, so the first problem we have here is quite a simple one. Which of the following is a fundamental unit? Okay, for A we have area, for B thrust, for C pressure, for D mass. Of course, mass is a fundamental quantity which has the units kilogram. Okay, our answer is mass. Alright, moving to the second one, it says distinguish between mass and weight. Name the instruments for measuring each. Okay, mass is the amount of matter contained in a body, while weight is the force exerted on a body by the gravitational pull of the earth. Okay, so mass just measures the amount of matter the body has. Okay, but weight in itself is the force exerted on matter by the earth, the gravitational pull of the earth. So there are two different things. Weight is a force that is applied on mass, while mass is just the amount of matter contained in the body. The mass of a body can be measured using the beam balance, while weights can be measured using a spring balance. Okay, so let's move on to the third one. From the third one, we are asked to find, first of all, the circumference of the earth in kilometers. Okay, given the radius as 6.37 times 10 raised to the power 6 meters. But to find the circumference in kilometers, so we know the earth is spherical, so the circumference of a sphere is 2 pi r. Alright, so that's where we begin. The circumference of a sphere is 2 pi r, and then if we bring in the value of the radius into the equation and that of pi, you can see that 2 pi r will be 2 times 3.142, 3.142 being the value of pi, then times our radius, which is 6.37 times 10 raised to the power 6 meters. Okay, so of course the unit for radius here is meters. The unit for pi is, pi is a dimensionless constant, so there's no unit for pi. This 2 is also dimensionless, so there's no unit for 2. So we just have one unit, which is meters. So if we multiply this out, we have 40029,080 meters. Okay, which is approximately 40 million meters. Alright, so you can see this is really large. This is really large, and most people will not be able to relate with 40 million meters. Okay, so we can actually decide to bring this down to a relatable form. Okay, so let's take let's do what they asked us to do. They asked us to present this in kilometers. Okay, so if we are to do that, remember what I talked about. If we are to convert this to kilometers, we bring in, all we need to do is just to divide this value by 1,000, because of course kilo is 1,000. So we just divide this value by 1,000 and we get our answer in kilometers. Okay, so this whole 1,000 divided by 1,000 I did here is just to make us understand where the k comes from. Of course, we have to have 1,000 here to represent k, and another 1,000 here, which goes into this equation to sort this whole number out. But then remember that 1,000 divided by 1,000 is 1, so this doesn't change the value of this guy here. All we're using it to do here is we're using it to modify, not to change the value. So we're going to get the same value but a modified version. Okay, so this 1,000 will turn it to our k, which is kilo, while this one goes into the equation here to bring this down to a more relatable term. So you can see that we have approximately 40,000 kilometers. Okay, which can be represented as 4.0 times 10 raised to the power 4 kilometer. Okay, so I don't want us to get confused by this. Alright, so basically what you just need to do is, once you have a value you want to change to maybe a kilometer or something, all you need to do is just divide the value by 1000. You can put your k, you can write down your k here, okay, divided by 1000. I'm sure we understand that perfectly. So once you just divide the value by 1000, you're going to get your value, your number in kilometers. Okay, all right. So the second question we're asked is to find the surface area in square kilometers. Okay, so the surface area of a sphere is 4 pi r squared. Once again, we're taking this formula because the earth is spherical. Okay, so 4 pi r squared, if we bring in the radius into the equation, of course we're going to have 4 times 3.142, which is the value for pi, times 6.37 times 10 raised to the power 6 raised to the power of 2, because the radius is squared here. Now our unit becomes meters squared. Okay, of course pi is dimensionless, 4 is dimensionless. So if we multiply this out, we're going to be having 5.099 times 10 raised to the power 14 meters squared. Now this is where it gets a little tricky and you have to pay attention. If we have the meter squared, if you need to convert this to kilo, okay, we have to acknowledge the fact that we have meter squared. That's, we have 1 meter multiplying another meter to have a square. That's, we're talking about 2 different lengths. Okay, so in that case we're going to be bringing in 1000, but it's going to be squared. So let's not forget, okay, this is the same as just putting a k here. All right, so we can write 5.099 times 10 raised to the power 14 times k over 1000 squared. Oh, this is k squared, not just k. Okay, let's not forget our squared. So k squared over 1000 squared in this case. All right, so basically we can just divide this value by 1000 squared to get kilometer squared. You know, this idea of kilometer, this square is not just on the meter, it's on both. Don't see it as meters squared and kilo is on its own. No, it's kilometer squared. Both of them are squared. So if you're bringing in the kilo into this equation, you have to be sure that your kilo is also squared so that it can give you your correct answer. Otherwise, you'll be bringing in a single kilo into this and the value will be wrong. So we're going to be having 5.099 times 10 raised to the power 8 if we simplify this. Okay, so the last question for number 3 is to find the value in cubic kilometers. So volume of a sphere is 4 pi over 3 times r cubed. So if we bring in the radius into the equation, we have 4 times 3.142 divided by 3 times the radius raised to the power of 3, and check, and you can see that here the unit is meters cubed. Of course our radius is raised to the power of 3, so the unit for radius is also raised to the power of 3. And if we're bringing in the kilometer, if we're bringing in the kilo into this expression, it has to also be to the power of 3. So all we basically do is just to divide our answer, which is 1.083 times 10 raised to the power of 21. We just divide our answer by 1000 raised to the power of 3, and so basically all we do is divide this answer by raised to the power of 3 and we'll get this. Okay, 1.083 times 10 raised to the power 12 kilometers cube. All right, okay, so let's look at number 4. Number 4 talks about a sphere of radius r moving with a velocity v under streamlined condition in a viscous fluid, expressing a retarding force given by F equal to k rho v, where k is a constant, and we're asked to derive the SI unit of k in terms of the base unit. So if you're asked to derive the SI unit of k, okay, we look at the expression F equal to k rho v. All right, we'll see that F is force, and of course we know the unit for force. All right, then we have the unit for r and the unit for v. okay, because F is force. We know force is kilogram meters per second squared. We know R is radius, which has the unit meters, and we know that V is velocity, whose unit is meters per second. All right. So once we have this, we are asked to find the unit of K. Okay. So one other thing with solving problems like this is proper interpretation of the question. Okay, you have to understand what the question is asking you to do. So in this case, it's asking us to find the unit of K, okay, in terms of the base unit. So since we have this other unit, it's going to be easy to find the unit of K. So what do? We make K the subject of formula. Okay, we're going to be having K equal to F over RV, right? So this is what we're going to be having. So in this case, we're going to bring in the unit of F, which is kilogram meters per second squared, and then divide it by the unit of R, which is M, and the unit of V, which is meters per second. Okay, so if we try to simplify this, obviously we'll see that this M here can be knocked off by this M here, okay, leaving us with kilogram per second squared and meters per second as denominator. So if we move our denominator upwards, we're going to have kilogram per meter. This per meter comes from this meter down here. So per meter per second squared, which is this one, then per second, which is this. Okay, so we have s raised to the power minus 2 plus 1, which would then give us from indices, we know that this would give us s raised to the power minus 1, because minus 2 plus 1 is minus 1. Okay, so our answer becomes kilogram per meter per second. All right.